y equals to mx plus c type of linear function. So already we know how to draw y equals to mx type of function. That is the different thing. This is a totally new thing. Y means we know that that is y coordinate, x means x coordinate. There is no any changes with that. X is called as independent variable. Okay, x is called as independent variable because when the x is changing, y will change. We know that. Just think about it. X is negative 2 to negative 2, 0 to. So accordingly, according to the graph equation, y will change. But there is no any factor that is affecting x. X is an independent variable. With respect to x, y is changing. If the x is negative 2, y is a different value. The x is negative 1, according to the change of x, y is changing. So x is called as independent variable. There is no any external factors which are affecting the x. Y is a dependent variable. In the while doing the example, I will explain. M is same as previous. M is a gradient or slope of the function, gradient or slope. And now a new thing appearing here, the positive c. What is meant by positive c? Positive c, that is showing some kind of identificational feature in our straight linear function, that is called as intercept. Okay, intercept. You have to be familiar with this terminology. Slope, gradient or slope, intercept, and x is, I told you, x is not changing with respect to any other factor. So x is called as independent variable. Or else we can use discrete variables. That means x is a single value, not a series of value. X is a single value, independent variable. With respect to the change of x, y is changing. So y is called as dependent variable. Dependent variable. Okay. So y equals to mx plus c. Y is a dependent variable. X is independent variable. M is gradient or slope. C is intercept. Only by dealing with this data, we cannot obtain anything. We need to plot a graph to identify these terms. That's what we are going to do here. So let's make a graph equation. The graph equation in this type. Y equals to mx plus c. 2x plus 1. Okay, 2x plus 1. M and c. Y and x doesn't change. Okay, y and x doesn't change. M and c, it can be substituted by some numbers to create different formulas. As humans, we are having our own names. Now, likewise, the graphs are also having their own signatures. That is changing with respect to the change of m and c values accordingly. So, for this particular graph which we are going to draw, that graph equation is y equals to mx plus c. So m is 2, c is 1. Okay. Let's have a look how to find the y coordinates when the x coordinates were given. For that, I will give you the x coordinate as negative 3, no, negative 2, negative 1, 0, 1 and 2. These are the given x values, because in the exam itself, in the examiner itself, they will offer you the x variable. So that's why that's called as independent variable. We cannot change the given value. But think about the y. When x is this one, y value is something. When x is changing with respect to the x change, correspondingly y also changing. That's why y is mentioned as depending variable, dependent variable. Y is equals to 2 times x plus 1. So let's substitute that one. 2x plus 1. That is the graph formula. 2 times, at this occasion, the x value is negative 2. 2 times of negative 2 plus 1. 2 times of negative 2 means that is negative 4 plus 1. negative 4 plus 1, it would be negative 3. Just do the substitution for x and solve to get the coordinate for y. Thereafter, for negative 1, 2 times x plus 1. 2 times of, in this occasion, the x value is negative 1. 2 times of negative 1 plus 1. 2 times of negative 1, it would be negative 2 plus 1. Amongst multiplication and addition, you should give priority to multiplication according to BODMAS rule. Negative 2 plus 1, it is negative 1. Next, substitution of 0. 2 times of 0 plus 1. 2 multiplied with 0, it is 0 plus 1, it would be plus 1 itself. Next, substitution of 1. 2 times of 1 plus 1. 2 times of 1, that is 2 plus 1, it would be 3. Then finally, substitution of number 2. 2 times of 2 instead of x, I am just substituting the 2. That's all. Plus 1. So 2 times 2, 4 plus 1, it would be 5. Okay. Our work is almost done. Almost half of the work that is done. We just identify y and x values to write the coordinates. Thereafter, planning and execution. What are the minimum and maximum values needed in x and y before plotting the graph? In x, the minimum value is negative 2, maximum value is positive 2. Y minimum value is negative 3, maximum value is positive 5. Likewise, let's plan and properly draw a compact graph. Okay, here x value is negative 2, negative 1, 0, 1 and 2. Okay, this is our x-axis. In y-axis, minimum is negative 3, negative 1, negative 2 and negative 3. In positive, the maximum value 5, 1, 2, 3, 4 and 5. This is for y-axis. Then just mark the coordinates. That's all. When x is negative 2, y is negative 3. X is negative 2, y is negative 3. Okay. First one, mark the coordinates. Around that, just draw a small circle to ensure there is a coordinate. Next coordinate is y is negative 1, x is also negative 1. Here. Next coordinate y is 0. Sorry. X is 0, y is 1. X is 0, y is 1. Here. X is 0, y is 1. That means here. Thereafter, x is 1, y should be 3. Y should be 3. Here. Then final coordinate, it would be x is 2, y is 5. The maximum values in both. Here. Okay. So after that, just ensure the values you plotted are correct or wrong. Negative 2, negative 3. Negative 1, negative 1. 0, 1. 1, 3. 2, 5. Yes, all are correct. Now, let's connect them by using our straight line. So, this would be our precise graph. The graph equation is y equals to 2x plus 1. Y equals to 2x plus 1. All right. That's all. Okay, by looking at this graph, we can observe some features. What are them? As if the gradient is positive, we know that if the gradient of the graph is, function is positive, that should have an acute angle with x-axis positive region. If the gradient is positive, no matter what the number, the gradient is a positive one, it will create an acute angle with respect to x-axis positive region. Okay, that condition was satisfied. Second one, look at this intercept. We know the gradient means the slope with respect to x-axis, positive or negative according to the gradient value, it might change, but it should create an acute angle. If it is a positive with positive region, if the gradient is negative with negative region. Next, this positive one, this is called as intercept. Intercept means in these kind of graphs, intercept is showing where our function will intersect with y-axis. Where our function, this is our function, where our function is intersected with y-axis. This is our y-axis, this is our function. So by observing that, we can clearly see in the formula the positive one. Here we can see that the function is intersecting with y-axis at exactly positive 1. So by looking at the graph equation, we can analyze one that the intercept is the place where our y-axis and our y-axis and our function are intersecting. Intersecting place with y-axis, that's called as intercept. Remind this, okay, you should remember this. That's why I'm explaining everything again and again. Nothing new. To draw the graph, that is simple, but from here there is an additional thing. From that you can identify the intercept. First observation is this graph is a straight line graph, linear graph, linear function, straight graph, straight line. And second one, the observation with intercept. Since this graph is y equals to mx plus c type, m means the gradient and c means intercept. It has an intercept. If it doesn't have any intercept, it is categorized as y equals to mx type of graph. As you remember that in our previous example, we discussed that y equals to mx means that graph is going through the origin because it doesn't have any intercept. The intercept is 0. That's why that is going through 0. If it has an intercept, definitely that should intersect with y-axis at that point. Since the intercept is positive 1, 0, positive 1, 0, positive 1. At this coordinate, our function will intersect y-axis, will intersect with y-axis, intersects with y-axis. Okay, this is an important thing. If it has an intercept, you should take it into account. Then, if the gradient, so previously I explained you, the gradient is a positive value. So m is greater than 0. Okay, m is greater than 0, or else we can identify this one as m is a positive value. In those cases, the function will have an acute angle with respect to x-axis positive region. Acute angle with x-axis positive region. Okay. These are the observations. Not only drawing the graph. While drawing, you have to analyze the characteristics. This is a straight line graph. Whether this is going to the origin or not. If not, what would be our intercept? Then by looking at the gradient, we have to make sure it is having an acute angle with respect to, don't come to here. Okay, don't come to here. Just stick with here. You can clearly see now. This is an acute angle. With respect to x-axis positive region, this is creating an acute angle. That's all about this y equals to 2x plus 1 type of